Homework 39, we are going to do a chapter on limits, which will be homework 39 and homework 40. A limit is the value that your expression approaches as it goes to whichever number. In this case, as we approach 0. So we're going to go from both ends, -1 towards 0, +1 towards 0, and see what value it approaches. The limit doesn't necessarily have to be the same number as when we put 0 in for our x's, but a lot of times it is, but sometimes we have graphs with strange things on there, and so when they give you the definition of a limit, they'll say it's the value that it approaches as it comes from each side of your number. And so if they both come towards the same number, that's the limit. You just kind of narrow it down into the middle. So they've completed some of your table for you here. They're going to have you do some calculations with these other values here. So they did the one for -1. They did -1/10. So now we're going to do -1/100th. We're just going to substitute it into the original function and find what our value is equal to. So we are going to take -0.01 plus 4. We're going to raise it to the third power, minus 64. On the bottom, we're going to take 4 times -0.04. If I'm going to use my calculator, I want to do the top separately from the bottom. So I'm just going to punch the whole top part in and find my answer, punch the bottom part in and find my answer, and then simplify it from there. I could do this separately and then subtract the 64, but I should be all right punching all of that in just like it looks, since my calculator knows the order of operations. So parentheses, -0.01 plus 4, close my parentheses. I'm going to cube that. So either the x cubed button or caret 3 to the third power, and then minus 64 from the end. So I get -0.478801. Try not to round off your numbers as you're doing your work. Once you're done, you're going to round your answer to 4 decimal places, but before that, you want to try not to do any rounding. On the bottom, 4 times negative, I put a 4 in there, that's not right. Let me fix that. We substituted in 0.01. That's what I should be doing. I already multiplied. So, fixing that, 4 times -0.01 gives me -0.04. So now I'm going to take the top divided by the bottom. So -0.478801 divided by -0.04 gives me 11.970025. We are going to round off to 4 decimal places on our final answer, and so we are going to have 11.9700 in here for when we evaluated it at -100th. We're going to do the same thing, only now we're going to use -1,000ths. So we are going to have -0.001 plus 4 raised to the third power minus 64 over 4 times -0.001. So again, calculating the top, parentheses, -0.001 plus 4, close my parenthesis, to the third power, minus 64 equals. I'm getting -0.479880001. On the bottom, 4 times -0.001 gives me -0.004. So dividing that out, -0.479880001 divided by -0.004 gives me 11, whoops, Let me punch that in again. Negative 0.47988,001 divided by negative 0.004. Something is not correct there. Let me check my top number again. I know my bottom number is right. So, top number again, parentheses, negative 0.001 plus 4, close my parentheses, cubed, minus 64 equals, I left a 0 out when I wrote it down, negative 0.04988,001. So, negative 0.04988,001 divided by negative 0.004 gave me, that looks better, 11.9970025. I knew since this was 9 and then 11 and these ones were 12, I should get 11 point something, and so when I had the wrong number on my calculator, I knew I did something wrong. I had to go back and check my work. Rounding this off to 4 decimal places, I have, I'm going to write it up here, 11.9970. That's going to go in that box there. So, as I get closer and closer and closer to 0, I went 9, 11.7, 11.97, 11.997. Here I'm doing 15, 12.3, 12.03, 12.003. In between those then, we can say that, oh, as we approach 0, we're getting closer and closer and closer to 12. Ah, there it is. I was supposed to put that in there. The limit as it approached 0 was 12. Number 2 then, same thing. This time we are finding the limit of this expression as we approach 4. So again, they're going to go from 3 to 3.5 to 3.95 to 3.999. Coming the other way, 5 to 4.5 to 4.05 to 4.001. They've calculated some of them. They give us a couple that they want us to calculate, and so we're going to plug 3.999 in for our x's. So 2 times the square root of 3 times 3.999 minus 8 minus 4 over 3.999 minus 4. Now in this one you want to be careful when you put this into your calculator. I would do this part under the square root first, take the square root of your answer, times that by 2, then minus the 4. Otherwise I've got to have a bunch of parentheses in there. So I'm going to start 3 times 3.999 gives me 11.997. I'm going to minus my 8, gives me 3.997. So under the square root I have 3.997. I'm then going to take the square root of that number. So I could retype it in, but you have a button on the very bottom next to the equal that says ANS. So I can hit square root of the answer, and it gives me 1.999249859. 1.999 and a bunch of other stuff. Now after I take the square root of this number, I have to times 2. So times 2 gives me 3.998 minus my 4, get equals again. So I get negative 0.001500281. Again, I don't want to round that off until the very end, so I'm going to write the whole thing that shows up on my calculator. On the bottom, 3.999 minus 4 gives me negative 0.001. So now I'm going to divide. Negative 0.0015000281 divided by negative 0.001 gives me 1.500281. I'm going to 4 decimal places, so that means I'm going to have to round that one up. So I'm going to say 1.5003 is what I get when I round it off to 4 decimal places. So notice here I was looking to see, did my answer come up close to with what I was getting before? It did, so that would make sense to have that answer. Over here, I'm going to put in 4.001. So 2 times the square root of 3 times 4.001 minus 8, then the minus 4 on the end, and then I'm going to have 4.001 minus 4. So again, I'm going to start underneath the square root. 3 times 4.001 gives me 12.003. I'm going to minus the 8 from that. Gives me 4.003. I've got to take the square root of that. So square root of my answer gives me 2.0007. I'm going to times it by the 2 in front, which is 4.0014. I'm going to minus the 4 from that. Gives me 0.001499718 on my calculator. On the bottom, if I take 4.001 minus 4, I'm going to get 0.001. So I'm going to take my top number, which is already in my calculator since I didn't use my subtraction down here. So 0.001499718 divided by 0.001 gives me 1.49971855. To 4 decimal places, I go to the 7. There's a 1 behind it, so I'm going to leave that one alone. 1.4997. So I can see here, as I get closer and closer to 4, the middle in between these two numbers looks like it's going to be 1.5. So 1.5 would be my limit as x approaches 4 for that crazy expression they have up there. And right down there, she left a spot, 1.5. You will have to type in this answer, and your limit on Alice. One more of those. Number 3, we are going to find our limit as x approaches 5. So they did 4, 4.5, 4.95, 4.999, and then they did 6, 5.5. We're going to do 5.05 and 5.001. So 7 parentheses, 5 minus 5.05. On the bottom, 25 minus 5.05 squared. Again, I'm going to do the top separately from the bottom. I don't have any weird square roots or anything, so I should just be able to type in the whole top. So 7 parentheses, 5 minus 5.05, close my parenthesis, gives me negative 0.35. On the bottom, 25 minus parentheses 5.05, close my parentheses and square that, would give me negative 0.5025. And so I'm going to divide negative 0.35 divided by negative 0.5025 gives me 0.6965174112. So to 4 decimal places, there's a 1 behind there. I'm going to have 0.6965 when I evaluate at 5.05. If I do the other one, I'm going to use 5.001. So 7 times 5 minus 5.001 over 25 minus 5.001 squared. Notice I put parentheses around my 5.001 there on the bottom just to be on the safe side. So on the top, 7 parentheses, 5 minus 5.001, close my parentheses, gives me negative 0.007. On the bottom, 25 minus parentheses 5.001, close my parentheses, square that. If I hit equals, I get negative 0.010001. So negative 0.007 divided by negative 0.10001 gives me 0.0, oops, something's not right. Let me check my calculations. I can tell I'm off because I'm not getting 0.69. 25 minus 5.001 squared gave me 0.01, 3 zeros and a 1. Okay. On the top, negative 0.007 divided by negative 0.01001 gives me, there we go, that looks better. I must have punched something in wrong. That's why it's always good to double check. 0.699300699. To 4 decimal places then, we have 0.6993. So we had 0.63, 0.666, 0.696, 0.993. Here we had 0.7778, 0.7368, 0.7035, 0.7001. So we can see as we approach 5, we're getting closer and closer to 0.7. So the limit as x approaches 5 for my expression is 0.7. So one way of evaluating my limit is to make my table and find values as x approaches the number from each side and then determine what the middle number is. We might have to use that, we will have to use that label later on some of the ones that we're going to evaluate using our rules. And so we won't make this big a table, we'll only do a couple, but will give us an idea of what number it's approaching as we evaluate. 4, 5, and 6, we're finding the limits from a graph. And so basically we're going to look at the limit from each side as we approach the value we're looking for. And if the limit as we approach from the negative side is, or the positive side is the same as the limit as we approach from the negative side, then the limit is whatever that number is. If my values are 2 different numbers, then my limit does not exist. So this is telling me of my graph H, as x approaches negative 1 from the positive side. So here's where negative 1 is. As I approach it from the positive side, my value gets closer and closer to 2. If I do my limit of my function as x approaches negative 1 from the negative direction, I'm coming from this direction, I'm going to have 3 for my limit. Since those 2 numbers are not the same number, then we're going to say that our limit does not exist. So the only way a limit exists is if it approaches the same number as you come from both directions. Otherwise, your limit does not exist. So if we look at number 5. Number 5, we're looking at our function h as x approaches negative 2 from the negative direction. So I'm approaching negative 2 from the negative direction. My limit here would be 1. This tells us to approach negative 2 from the positive direction. So if I come from the positive direction as I go to negative 2, I'm going to end up at negative 1. Again, those 2 numbers are not the same thing, so my limit does not exist as x approaches negative 2 because I have 2 different values when I come from the negative direction and when I come from the positive direction. On my third one here, I have a function g. I'm going to say as x approaches 4 from the positive direction. So from the positive direction, here's my 4, I'm coming this way, and so I'm approaching 2. On the second part, as x approaches 4 from the negative direction, well, it doesn't mean I'm starting in the negative spot, it just means I'm on the other side of 4, so I'm coming from the numbers that are smaller than 4. Remember on our table when we were doing 5, they started at 6 and went to 4, then they started at, or 6 and went to 5, and then they started at 4 and went to 5. So here, when they say coming from the positive direction, I'm coming from the right side. When they say coming from the negative direction, I'm coming from the left side. I'm approaching 2 for both of those, so this time we can say, oh yes, this one does have a limit. As x approaches 4, both from the positive direction and the negative direction, or both from the left and the right, they're both coming towards 2. So when I look at my graph and it has the plus sign, it means I'm coming from the positive direction, but it really means I'm coming from the right side of my graph. Here, I'm coming from the negative direction, I'm coming from the left side of that point, and if I have the same value, then a limit does exist at that value. If they're not the same value, then the limit does not exist. 7, 8, and 9, and probably a lot of the rest ones, are finding limits when I have a function on here. So I'm going to find the limit as x approaches 1. If the limit does not exist, I'm going to put does not exist. So we want to use the limit laws. So I'm going to go over here and bring up my limit laws. Again, if you go to the dictionary and type in limit laws, you can print out this page or bring up this page. So if it says, I'm finding the limit as x approaches a for c, and c is a constant term. So for example, if I am finding the limit as x approaches 2 of 3, my answer is just going to be 3. That's what that's saying, is if I have a constant there, the limit is always the exact same number because I'm always going to have 3's. The second one says if I have the limit of x approaches a of just x, I'm going to get an a. If I have the limit of x approaches 2 of x, what I'm doing is I'm putting 2 in for the x, and so my answer is going to be a 2. If x were 5, I would get 5. Various things. Now these rest of these first ones are kind of weird. All they're doing is saying that if I have a function and I have f of x and g of x, I can find the limit of each part of that separately and then add my answers together. So on the third one there, if I would have something like the, well, it's going to write eventually here. Let me see if I can get it to work. The little thing wants to spin. Didn't like me using the eraser. If I would have the limit as x approaches 2 of 2x plus 3x, that I would find the limit of this and the limit of this and add my answers together. Well, if I'm going to find the limit of 2x, I'm going to take 2 times 2, which is 4. If I'm going to find the limit of 3x, I would take 3 times 2, which is 6, so my limit ends up being 10. So it's just saying, oh, I could split them apart and find the limit of each of them separately, and then I get my answer. Same thing with number 4. If I'm subtracting, I can find the limit of each part and subtract them, and that's going to give me my answer. Number 5 is if it's multiplied by something. So same kind of thing. I would find the limit of it, and then I'd multiply it by some value. If the two things are multiplied together. Now number 7 is one that's maybe a little more important to look at, because basically it's a little different than, well, it's not really a little different, but it's important. If I have a fraction, normally I would find the limit of the top, the limit of the bottom, and then divide my two answers. But what I have to be careful of on my fraction is that my denominator is not 0. We know that division by 0 is undefined. We're going to have a whole bunch of them where the bottom is 0, and we have to take a different approach to finding the limit other than just plugging the number in and solving. And then we get back to, okay, if I raise to a power, if I'm going to do the square root, If I, again, have something, a constant term raised to a power and a square root. So most of them, when we evaluate a limit, all we're really doing is substituting the number that it approaches in for the x's and solve it. The only one we have to watch out for is when we have division by 0, and then we have to take a different approach to solving the problem. So those are your limit laws. Nothing that you have to memorize. They're really not that important, other than when you get to the ones with 0 on the bottom. So for most of your limits, if you're going to find the limit of a function as x approaches 1, all you're going to do is put 1 into the function and solve it. So I'm going to find the top and the bottom. So I'm going to take 3 times 1 squared minus 4 times 1 plus 3, and then the bottom 1 minus 6. So here 1 squared is 1, 3 times 1 is still 3, negative 4 times 1 would be minus 4, plus 3. 3 plus 3 is 6, 6 minus 4 would give me 2. On the bottom, 1 minus 6 is negative 5. So my limit as x approaches 1 of this function is going to be negative 2/5. Same thing on number 8. All I'm really going to do to find the limit as x approaches 3 is to put 3 in for my x's. As long as the denominator is not 0, we're good. So I'm going to start by doing 3 cubed plus 8. And then I'm going to take 2 times 3 minus 5. 3 cubed is 27. 27 plus 8 would be 35. On the bottom, 2 times 3 is 6. 6 minus 5 is 1. So my limit as x approaches 3 would be 35. Number 9. Here we're finding the limit as x approaches negative 3. Same thing, I'm just going to plug it into my expression. As long as the denominator is not 0, we're all right. So we're going to take 3 times negative 3 plus 3. On the bottom, 3 times negative 3 squared plus 2 times negative 3 minus 9. So 3 times negative 3 would be negative 3, or negative 9. 3 times negative 3 is negative 9. Negative 9 plus 3 would be negative 6. On the bottom, negative 3 squared would be 9. 3 times 9 is 27. 2 times negative 3 would be minus 6 and minus 9. So 27 minus 15 would give me 12. Well, if I have negative 6 over 12, it reduces down to negative 1/2. So my limit as x approaches negative 3 would simply be negative 1/2. So first, easiest way of finding my limit of a function is just to put the number in for your x's and evaluate the expression at that value. Now sometimes we have what's called a piecewise defined function. A piecewise function just means I have different equations depending on what x is equal to. And so depending on which direction I'm coming from, I might use the top equation, I might use the bottom equation, and so I just look at my question here. First of all, I'm finding the limit of my function as x approaches negative 2 from the negative direction. So in other words, I'm going to use the values that are less than negative 2. If I'm approaching from the negative direction, then I'm using the less than ones, right? So I am going to use this expression up here, and so I'm going to put negative 2 in for my x's. So I'd have minus a negative 2 squared minus 3 times negative 2 minus 1. So negative 2 squared would be 4. It has the minus sign in front, so negative 4 plus 6 minus 1. That would be minus 5 plus 6, which gives me 1 as I approach from the negative direction. If I do part B, as I approach negative 2 from the positive direction, in other words, I'm greater than, I wrote a less than, in other words, I'm coming towards negative 2, so I want the ones that are greater than negative 2 because I'm coming from the positive side, so the number's bigger than negative 2. So in this case, I'm going to use this function. So I would say negative 2 plus 1 squared. Well, a negative 2 plus 1 is negative 1. A negative 1 squared is a positive 1. Since both of these two numbers are the same thing, as I approach from both the negative direction and the positive direction, I approach 1. Therefore, my limit as x approaches negative 2 is a positive 1. If these two numbers are not the same, then my limit would not exist. So on number 11, this one, I have one with an absolute value in there, and so I have to think about my rules for absolute value. And so this is one where if I would put the negative 2 in there, I would get a 0. So I want to think about if I approached from the positive direction. So if I have a negative 2 and I'm approaching it from the positive direction, I might use negative 1.999, something really close to negative 2. Here, if I have negative 2 and I'm approaching from the negative direction, I might use negative 2.001. Remember problems 1, 2, 3 where we had to plug the numbers in and see what it approached? This is one because when I put the negative 2 in there, I get 0, is one I would have to put values in and evaluate those values. So if I think about this one, negative 1.999 plus 2 and the absolute value of negative 1.999 plus 2. I put my calculator somewhere. Must be over there. Now this one works on this one because you notice you have the exact same expression on the top and on the bottom. It's just one has the absolute value and the other doesn't. If this was a plus 3 and that was a plus 4, I may have to do it a little bit differently. But because it's the exact same thing, and normally I would have this over itself as 1, I've got to do it just slightly differently. So, if I have negative 1.999 plus 2, I would get a positive 0.001. If I have negative 1.999 plus 2 again, I get 0.001. Since this is positive and it's in the absolute value, it's going to stay positive. And then anything divided by itself is going to stay positive 1. Now if we look at the second part of that, if I use negative 2.001 plus 2, and then the absolute value of negative 2.001 plus 2, this would give me negative 0.001. This would give me negative 0.001, but I have to do the absolute value. And when I do the absolute value, it's going to be a positive. So I have a negative over a positive, which means that one's going to approach a negative 1. If you look at the Alex explanation, they're not going to put numbers in there. They're just going to say, oh, well, if this one's positive, then I'm going to get a positive over a positive, and it's going to be positive. Here, if this is coming from the negative, I'm going to get a negative on top, but a positive on the bottom, and I'm going to get a negative. Well, I like to use numbers. They make more sense, so I pick numbers that make sense and plug them in. Because in this case, this is positive 1 and this is negative 1, the limit here does not exist because they don't approach the same value as I approach from the positive direction and the negative direction. Number 12, we're back to a piecewise one where we have to evaluate this. Here, if x does not equal 3, I would use this equation. The only time I'm going to use this equation is if x equals 3. So again, if I think about this, as I approach 3 from the negative direction, I would use 2.999. That's not exactly equal to 3, so I would use this function, but I'm going to use it with a 3 in there since x is approaching 3. Same thing here on this one. if I were thinking about approaching from the positive direction, I'd use 3.001, but again, that's not exactly equal to 3. So for both of these, even though the limit is approaching 3 from the negative and the positive direction, I'm going to use this top equation. However, when I use that top equation, I'm using the 3 that I'm approaching. So I'm going to have negative 3 squared plus 3 times 3 plus 3, which gives me negative 9 plus 9 plus 3, which happens to be 3. I'm using the exact same equation for this one, so I'm going to get the exact same answer. So the limit as x approaches 3 is going to be 3 because I get the same answer for both of them. So what would be happening on this graph is you would have something like this where it's going to 3 and going to 3, and then the 5 has a filled in dot. So even though here at exactly x equals 3, I'm at 5, my limit as I approach 3 is 3. So it's not always true that the limit is the same thing as the point where this is exactly equal to this. It's kind of strange, I know. So that's why they give the definition of the limit as you approach that value. Do they both approach the same number? Not necessarily what is it when it's exactly equal to that value. So as I approach negative 3, I'm still not exactly equal to 3. I use that equation. As I approach 3 from the positive direction, I'm not exactly equal to 3. I use this equation. And so I still use the 3 when I substitute it in. That's just telling me which equation to use. My limit then is going to be 3, even though at x equals 3, I have a 5. It's kind of weird. 13, 14, and 15 are, again, finding the limit using the limit laws. What's going to happen on these ones is if I would put the 3 in and evaluate it directly, I would have 3 squared minus 3 minus 6 over 3 minus 3. Well, you can see right away in the bottom you're going to get 0. But what also happens here is 3 squared is 9. 9 minus 3 minus 6 is 9. And I get the special case where I have 0 over 0. If I get 0 over 0, I can't evaluate my limit directly unless I can rewrite my problem in a different form. So on these first ones here, we're going to have all quadratic expressions in them. And if we have a quadratic expression, we can try to factor it out and then cancel out our common factors so that we have an expression that isn't quite as complicated as the original one. So if you get the case where you try to evaluate it directly and you get 0 over 0, you have to rewrite that in a different form. So if I factored the top, I would have t and t. The end is negative, so a plus and a minus. Factors of 6 that give us minus 1, we'd have to have a minus 3 and a plus 2. Well, you probably notice on the bottom that we have 3 minus t instead of t minus 3. So if we factored out a negative 1, this would become negative 3 and that would become positive t, or t minus 3. So that we can cancel this expression, and now we have t plus 2 over negative 1. Now that's an expression that we can evaluate at 3 directly. So we are going to then put the 3 in for our t. If I have 3 plus 2 over negative 1, 5 over negative 1 would be negative 5. So the limit of our expression as t approaches 3 is going to be negative 5. So a lot of times when you have that quadratic expression, you're going to end up factoring out and reducing your fraction down as much as you can, and it makes it easier to evaluate your expression. So on this one, again, we have that squared term in there, and if I would go as x approaches 0, again, if I put 0 in there, I get negative 2 squared, which is 4. 4 minus 4 is 0 on the top. 0 would also be on the bottom. So again, I'm going to get 0 over 0 if I try to evaluate it directly. And so I have to find another approach to evaluating that. Well, this one, I've got this expression. So to simplify it, I first of all have to square my negative 2 minus x. So I'm going to take negative 2 plus x. Negative 2 plus x times another negative 2 plus x minus my 4 all over x. So I'm going to FOIL that out and simplify my fraction if I can. So negative 2 times negative 2 would be 4. Negative 2x. Another negative 2x in the middle. X times x is x squared minus 4. Just keep working on the top here. I can see here that I'm going to have 4 minus 4, which is 0. So I'm going to have x squared. Negative 2x minus 2x would be minus 4x over x. So if I want to simplify this expression then, again I have to go back to, I need to factor this out. Here I have to factor out my greatest common factor. The greatest common factor there would just be an x. So I would have x times x minus 4 over x. Now I can simplify my expression because I can cancel out the x's. I just get x minus 4. So if I evaluate my expression as my limit approaches 0, 0 minus 4 gives me negative 4. So the limit as x approaches 0 of this expression is also just going to be negative 4. So in this one, we had to FOIL it out first, then we could factor our quadratic expression and reduce our fraction down to the lowest terms. Number 15, same kind of thing. This one I just have that quadratic expression up on the top. Again, I could plug my negative 1 in there and double check, but I know since that's the kind we're on, I'm going to end up with 0 over 0. And so I want to simplify this. And so I'm going to factor my top, x and x, a plus 4 and a plus 1 would give me plus 5. On the bottom, if I factor out the negative 1, I'm going to get a positive x and a positive 1. So again, I can just cancel out my x plus 1. I get x plus 4 over negative 1. So I'm finding the limit as x approaches negative 1. I'm going to put negative 1 in for my x. Negative 1 plus 4 is 3. 3 divided by negative 1 is negative 3. So in the event that you try to evaluate directly and you end up with 0 over 0 when you try to evaluate it directly, you have to rewrite it in simplest form. And if you have a quadratic expression, means you're probably going to factor it out and then reduce out your common factor. 16, 17, and 18, again, we're finding the limit by using limit laws. Again, on this one, if I try to evaluate this one directly, I would have 2 minus the square root of 1 plus 3, and then I have 1 minus 1 on the bottom. Well, 1 plus 3 is 4. The square root of 4 is 2. 2 minus 2 is 0. 1 minus 1 is 0. So again, these ones are going to be cases where you have 0 over 0. And if you get 0 over 0, you have to try to rewrite your expression in a different form. So on these ones, in order to rewrite them in a different form, these are ones where you're going to have a binomial, either numerator or denominator, and you're going to multiply by the conjugate, which is going to be really fun. So, if I have 2 minus the square root of x plus 3 over x minus 1, I'm going to multiply by 2 plus the square root of x plus 3. So, I'm just going to worry about foiling out the top part. So, 2 times 2 is 4. Then I'm going to get 2 plus 2 square root of x plus 3. And then in the inside, I'm going to get minus 2 square root of x plus 3. Purpose of multiplying by the conjugate, getting those opposite middle terms so that they cancel out. Then, negative times a positive is a negative. And when I square this, I'm going to have the square root of x plus 3 squared, because I had that times itself, right? Square root of x plus 3 times the square root of x plus 3. Well, when I square that square root, it cancels out. So this is going to just be x plus 3. It's just like when you take the square root of 3 and you square it, you get the square root of 9, which ends up just being the 3. You just get the same thing underneath. So if I take one square root times itself, squaring the square root cancels that out. You just get the x plus 3. I do need the parentheses because there's a minus sign in front of that, and I have to use my distributive property. So I'm going to get 4 minus x minus 3, which gives me negative x plus 1 on top. Now if I notice here, I have x minus 1. So in order to cancel that out, I could factor out a negative 1. So I'm going to have a negative 1 times negative x plus 1. And then I'm going to have my 2 plus the square root of x plus 3. Lovely. So here I'm going to be able to cancel this with this, putting a 1 on top. So I have 1 over negative 1 times 2 plus the square root of x plus 3. Now I have my expression in a simpler form. I can try to evaluate it directly or see if I have to continue trying to simplify that. So if I try to evaluate it directly, I'm going to put a 1 in for my x. So I'm going to have 1 on top, negative 1 times 2 plus the square root of 1 plus 3 is 4. The square root of 4 is 2. 2 plus 2 is 4. Negative 1 times 4 gives me negative 4. So I have 1 over negative 4, or negative 1/4. So the limit as x approaches 1 is going to be negative 1/4. So when I have a binomial in the numerator or the denominator, if I multiply by the conjugate, it's going to simplify my expression on the top. I would wait to FOIL out the bottom to see, because normally there's going to be something that's going to cancel out. So I wouldn't even FOIL out the other part until I've gotten done simplifying this part, which is what I did here. And then I looked and said, oh, I'm going to be able to cancel that out if I factor out my negative 1. And then, again, I'm probably not going to simplify much. I'm just going to plug my number in and say, okay, now does it work out where I get an answer instead of getting something like 0 over 0, which I did, negative 1/4. Number 17, same kind of thing. If I put my 3 in, I would have 3 minus 3 on top, which is 0. Here I would have 3 plus 1, which is 4. The square root of 4 is 2, and 2 minus 2 is 0. So again, I get 0 over 0. And so even though I try to evaluate it directly, I can't. And so I have to come up with some other method. So whenever I get that 0 over 0, when I plug my number in, I have to look at it and say, oh, okay, here's another one. I have a binomial on the bottom. Let's see if I can get rid of that. So x minus 3 on top. If I can get my board to work. On the bottom, I have 2 minus the square root of x plus 1. So I'm going to multiply by 2 plus the square root of x plus 1. And again, on the top part, I'm just going to leave that alone. So I'm going to have the x minus 3, and then I'm going to have 2 plus the square root of x plus 1. And I'm just going to FOIL out the bottom where I'm multiplying by my conjugate. 2 times 2 is 4. I'm going to get 2 plus 2 times the square root of x plus 1. Then I'm going to get minus 2 times the square root of x plus 1. Those are going to cancel. Here, a negative times a positive is a negative. And then when I take the square root of x plus 1 times the square root of x plus 1, that's squaring that. So I'm just going to get the x plus 1 that's underneath my square root. So I am going to have 4 minus x minus 1, which would be negative x plus 3. Again, you can see here that if I factor out my negative 1, I'm going to be able to cancel. So I'm going to make it negative 1 times negative x plus 3 times 2 plus the square root of x plus 1 over negative x plus 3. I can then cancel this out of there. So I'm just going to have negative 1 times 2 plus the square root of x plus 1. I've got that simplified as much as I can. I'm now going to evaluate it as x approaches 3. So I'm going to put 3 in for my x. Negative 1 times 2 plus the square root of 4. Square root of 4 is 2. 2 plus 2 is 4. Negative 1 times 4 gives me the limit of negative 4. So as x approaches 3, my expression is going to approach a limit of negative 4. All right, number 18, we want to find the limit as x approaches 1. So if I evaluate it directly, I would have 1 over 3 minus 1 minus a half over 1 minus 1. Well, here, 3 minus 1 would be 2. 1 half minus 1 half is going to give me 0. 1 minus 1 is also 0. So I have one of those where I have 0 over 0. I need to simplify my fraction then in order to put it in a different form so that I can evaluate it directly. So if I have 1 over 3 minus y minus 1 half over y minus 1. Here I have a complex fraction, a fraction within a fraction. I want to simplify that, so I'm going to multiply every term by my common denominator. So I'm going to multiply by 2 and 3 minus y. Here I'm going to multiply by 2 and 3 minus y. Down here I'm going to multiply by 2 and 3 minus y. So here the 3 minus y cancels out. 2 times 1 is 2. Here the 2's cancel out. Negative 1 times 3 would be minus 3. Negative times a negative is going to be a positive y. So on the top, I'm going to have y minus 3. No, not y minus 3. I'm going to have y minus 1. Y and 2 minus 3 would be minus 1. So I have y minus 1 on the top. On the bottom, I have y minus 1 times 2 times 3 minus y. So here I have a y minus 1 that I can cancel out. That makes that 1. So I have 1 over 2 times 3 minus y. I could use my distributive property and multiply that out if I want. Really not necessary. I've got my fraction in a simpler form. So now I can go ahead and evaluate it directly. So I'm going to put 1 in. And so I'm going to say 1 over 2 times 3 minus 1, give me 1 over 2 times 2, which gives me 1/4. And so 1/4 should be my answer. I notice there's a typo here. This really should say as y approaches 1, not x approaches 1. I'll fix that on your sheets. So, again, 17, 18, and 19, or 16, 17, and 18 are ones where if I try to evaluate it directly, I'm going to get 0 over 0. And so I have to find a way to simplify my fraction. If I have a binomial, can I multiply by the conjugate? If I have a complex fraction, can I multiply by the common denominator and get rid of the fractions? And so we had the ones before where we had quadratic expressions that we could then factor out and cancel. Same kind of thing's going to happen here. I want to try to get something in my fraction where I can do some canceling and make my fraction a little bit more reasonable so that when I try to evaluate it directly, I don't get 0 over 0.